13 years ago, I was working on my first mobile game about vampires that have to avoid light traps and get to their crypts before the dawn. It was all about avoiding the light, not only in the gameplay, because vampires, obviously, but also in the level setup, because me and my team just couldn't afford having that many lights placed in the levels. And the reason was, of course, performance limitations, and we had to fake a lot in lighting. That was a long time ago, but even today, some of those limitations still prevail, and many developers have to look for workarounds how to overcome them. All of this could change now because ARM will be releasing a new set of neurographic plugins for Unreal Engine for denoising, upscaling, and frame generation. And me and my team were lucky enough to be able to test and implement those plugins in our new project. And today, I will show you the new possibilities it has opened up for us. My name is Lukas Medek. I am an art director at Sumo Digital, and I have more than 20 years of experience in the game industry with all its ups and downs. And I spent a big chunk of the time working for indie studios, and sometimes I was the only artist responsible for the whole visual side of the game, so I know the whole process from early pre-production to the release. With that experience, I can always appreciate anything that could save the development time while raising the level of visual quality. And that's what the new plugins allow me to do. It may sound like a marketing fluff, but with this new tech, we can really work much more creatively with lighting. And what is more important, we can leave the former lighting restrictions behind. I'd like to give you an insight into the process of creating a mobile game that uses the most advanced features of Unreal Engine, like ray tracing, MegaLights, or actor sequences, and show you how those new possibilities are helping us to make the game beautiful, speed up the process of development, but also about the problems and limitations we have to face. I'd like to show an example of what is possible with the new tech. So let me introduce Project Buzz, where me and my team are able to test and apply new lighting approaches in a mobile game. So what is Project Buzz? Project Buzz is a third-person adventure game for mobile when players get into a role of an android that wakes up from deep sleep and start to explore a huge cave complex and try to finish a research that had started a long time ago. The main focus of the game is interaction with the environment, and players gather flying drones, we call them bees, through their journey and execute those interactions with them, ranging from very simple ones like unfolding the platform to more complex puzzles. Project Buzz uses semi-realistic assets and stylized lighting, and lighting is a core visual and gameplay element. The game is still in the development. We started working on it last year. And although the main objective is to create a showcase what is possible with the new tech on mobile, Project Buzz is not only a technological demo, but a full-scale game created by a small team consisting of just about 15 people. Odin Buzz is about lighting, and the art pillars are built around it. So the first art pillar, lights mean interactivity, is about connection between the interactions and lighting. And we try to bind almost every interaction in the game with some lighting changes. It's also connected to the second art pillar, reveal the hidden, which is about the players start usually in a very dark and gloomy environment that gradually light up with every player's interaction, revealing various secrets and hidden paths. The third art pillar, environment, is the star. Is pretty straightforward. It's about that we are not focusing on characters, animations, or cutscenes, but on the environment and the lighting change we can bring to the environment. Now that I've introduced Project Bus, let's talk about the plugins. The new suite will consist of two modules. One is a brand new denoiser and upscaler with better results and performance than the default Unreal Engine one. And the second is a frame generator, which allows us to have a better and smoother frame rate. What does it mean? The first plugin, NSSD, stands for Neural Supersampling and Denoising, allows us to render the frames only in a fraction of the final resolution. So we are allowed to render the game only in 540p, and the upscaler just do the job to upscale it to the final resolution, which is, considering the huge resolution of current mobiles, it's a great performance hit that we just don't need to take. And the second plugin, NFRU, that stands for Neural Frame Rate Upsampling, allows us to render the game only in 30 FPS and then generates an interpolated frame between every two real frames. As both plugins are part of the neurographics family, they need to be trained on the game content, and while NSSD is trained on the game content of the particular game, NFRU was pre-trained on a range of games, so it's applicable to a wide range of new games. I'm just an artist, so I don't know that much about the technical details, but if you want to know more, please attend Sergio Alepon's talk for more in-depth information. That will be happening today, I think in an hour. And as always, there is a price for enabling a new tech, and we had to think carefully when setting up our initial specs and limitations. So before I jump on the core of this talk, which is lighting, I would like to talk about the initial setup and what we've ended up with. So at the beginning, we wanted to play safe, so we set our triangle limit to 1 mil triangles, 1000 draw calls, 20 skeletal meshes on screen, and environmental texture density on 256 pixels per meter. It was a little bit worrying because we weren't sure that we can achieve the level of quality that we wanted. But in the end, we discovered that we can be much more generous. So we could double our triangle limit to 2 mil triangles, 2000 draw calls, 20 to 40 skeletal meshes on screen with a custom switcher to static mesh for ray traced shadows based on the distance from the player. And we could also scale up environment excellence in some cases from 256 to 512 pixels per meter. Now to the most interesting part, lighting Project Bus. And like I said, we can use the most advanced features Unreal offers. And one of those features is something I would not expect to see on mobile, and that is ray tracing. Thanks to the NSSD and NFRU, we are able to run ray traced shadows on mobile. And when enabled, we can use the benefits and also deal with cons of this feature as well. Let's take a look. Ray traced shadows, they just work great. And the biggest advantage are the high quality soft shadows that are precise and beautiful also in a big distance. We can also achieve this nice blend between the sharp shadow near the shadow caster and then more blurred shadow in the distance. And we can also avoid those usual problems or common problems or default Unreal Engine cascade shadow maps like gaps between the shadow caster and shadow or shadow bleeding. In Project Bus, we are using a lot of movable lights. That means a lot of moving shadows that produce a lot of noise. But this noise is handled by the NSSD plugin. There are also cons of ray traced shadows, so this is the list of the, let's say, most painful ones. So because of the additional reads and the alpha channels in textures, we have to limit or restrict completely alpha cutouts. We also have to limit world position offset, which is basically industry standard for every vertex animation, like grass swaying and stuff like that. But when enabled with a big, in a big scale, it can be a huge performance hit. So we are limiting the world position offset only to the close distance around the player. Currently, we can't use direction light, but good news is that direction light becomes supported by the MegaLights in the future Unreal Engine updates. We also have to limit use of the transparent materials because of the overdraw, especially when they are covering a big part of the screen. Before Bus, I could not imagine not to look at the number of lights in the levels, keeping their attenuations as low as possible and checking if there's any light where I can turn off shadow casting to gain a bit of performance. All that changed when I got an opportunity to enable MegaLights. I believe most of you already heard about the MegaLights, but let me do a quick summary. MegaLights was introduced in Unreal 5.5, and the main feature is that it allows us to use a huge number of movable lights with low performance impact. MegaLights uses ray traced shadows, that mean high quality soft shadows, and there is also a possibility to use expensive light sources like rectangular lights. There is an initial performance cost when MegaLights are enabled, but it grows only very slightly with adding more lights. So how we use MegaLights in Project Bus? As I said, with MegaLights, all lights in the project are dynamic, and we can really render hundreds of lights in one frame. We can also avoid this kind of mobile industry standard of baked static lighting with all its problems like low shadow quality depending on the light map UV resolution, lots of lighting errors, light bleeding and artifacts, and especially very long waiting times for baking with very unexpected results. We basically get what we see, and it's amazing because it really speeds up the process of development, and we can be sure that what we see in the editor then appears in the build. We can also use lights for various gameplay purposes, and the best thing is that it all runs on the phone. I would like to show you two examples of lighting levels in Project Bus. So in this first example, you can see this bee flying away from the player, activating all those light objects. And you can see in the top right corner that we are sitting on roughly 2,000, almost 700 lights in the levels. And here is an example of how the setup looks in the editor. So each of those small icons is one light. All of them are dynamic. Most of them have quite big attenuations, and the majority of them have shadow casting enabled. There is an example of the lighting setup of the sequence I showed, and we have our custom previewer for switching the states of lighting so we are able to check it outside the gameplay. Second example is slightly different. After the interaction, there is this big building that is gradually lighting up. And again, you can see that we are sitting on more than 2,700 lights in the level. Again, example of the setup. So each of those numbers is one light. Most of them in this example are rectangular lights, and the showcase of the sequence and the preview of the state change. As we are dealing with a lot of lighting changes in the project, we built a custom tool that we call Light Animator, and it allows us to switch between two states, we call them sleep and awake, where we can control light, colors, and opacity via curves. So you can see on the right that we are using a gradient ramp for color and opacity gradient ramp for intensity for each state. Then we just set the time loop and take the lights that needs to be affected or we want to be affected by a light animator, and the setup is done. With MegaLights, we can use hundreds of lights, so we had to sort them into multiple categories. So I would like to show a quick example of how the lighting process looks like in Project Bus. So we usually start with the very dark scene, only with the skylight that for this project we are keeping really low, the intensity of the skylight. And then we start to adding lights. So the first category, we call it static key lights. We call it static, but all those lights are still dynamic, still movable, but they usually don't change the positions in the level. And this is basically the basic layer of lights that sets the basic mood. Then we add static helper lights, which are lights that are used for fine-tuning, enhancing the silhouettes, or we use them for highlighting various objects. Those are usually spotlights with limited cone radiuses or point lights with very low attenuations. And the common perk of this category is there are no visible light sources. So those lights kind of helping the key lights to set up the mood. Next category, switchable lights, are usually lights used for interactive objects. So you can see, for example, those mushrooms. And their change affects the mood in the levels the most. And they can be usually turned on and off by the player. And this change is controlled by light animator, actor sequences, or blueprints. Another category, fake global illumination lights. And I'd like to stop here for a moment because we used multiple, or tried to use multiple automatic GI solutions. And Lumen proved to be too expensive regarding performance, and there were other options considered, but they were rejected due to art style and desire to keep the schedule on track because of various lighting errors, light bleeding, and such. So we ended up with using MegaLights again, and what we are doing in our levels is that we are basically scattering a lot of colored lights across the level to fake the global illumination. It's not suitable for every project. I wouldn't definitely do that for an open world game, but for a medium-sized or small-sized game, it's a great approach because we have more artistic control over the result. Gameplay fog and VFX lights, those lights are usually used for various gameplay purposes like projectors or interactive triggers, or for example for the volumetric light, because instead of using performance heavy particles with a lot of overdraw, we can just place a big rectangular light just under the surface, pump up the intensity of the volumetrics, and we can get a nice local volumetric fog. This is how the scene looks like where all those switchable objects are turned on. And this is the final lighting mix in the motion. There is one last category I would like to talk about, and it is movable key lights, because with these lights we can show the power of MegaLights the most. Movable key lights are usually attached to various actors like VFX systems or moving actors. They have big attenuations, and they of course have shadow casting on, and they can bring a lot of motion and dynamics to the scene. The last thing I would like to talk about are actor sequences. And this feature totally slipped from my side when I was watching Unreal updates. And although it's still experimental, it proves to be an enormous time saver. Before actor sequences, when I wanted to have a feature implemented, let's say change in an object after player's interaction, I went to the programmer, I gave him a list of actions that needs to be done. The program did this thing and sent it a result to me for feedback. And we were kind of iterating back and forth until the desired result. With the actor sequences, the process is much more streamlined because we can use the full power of Unreal Sequencer on per object basis. That means that we can just drag and drop an actor sequence component into any blueprint, do the minimal code support needed for the initial setup, and then the artists can take over the whole animation process. So ranging from changing intensities of lights, putting animation for skeletal meshes in, or just doing simple transforms of objects. It's a multifunctional solution, but it really saves a lot of time. So before we wrap up, I'd like to tell you how NSSD and NFRU affects the development of Project Bus. Most importantly, it frees up the space in the performance budget. So we are allowed to turn on MegaLights and ray tracing in our project. And it also can speed up the development process of visuals because we can get what we see and we can work with the fully dynamic environment. And it also adds a possibility to create an experience with a generous dynamic lighting, movable lights, and moving shadows. So who can benefit from an SSD, NFRU, and MegaLights? I would say that every mobile game developer that aims for high quality visuals, and even small teams can do that because the process is pretty fast, or previous studios that require precise shadows and a lot of dynamic lighting. But basically any developer that want to speed up the process of development, their game relies on 3D and they are aiming for high quality graphics. Now let's take a look at what we have seen today. I've introduced Project Bus, a new mobile game that will be using a new set of neurographic plugins for denoising, upscaling, and frame generation. I've described the functionality of those plugins and how they free up performance needed for enabling the most advanced features like ray tracing or MegaLights on mobile. I've told you about the pros and cons of ray tracing, then showed you what MegaLights offers and how they helps to light Project Bus in a few examples. The last feature I've talked about were actor sequences, how they can reduce back and forth between artists and programmers and speed up the process of development. As a last thing, I've made a summary of what benefits NSSD, NFRU, and MegaLights bring to development and who can benefit from them. But if there is one point I would like you to take away from this talk, it is that with the new possibilities that the features I described offer, we can leave the former lighting restrictions behind and find new ways of creative work with lighting on mobile. Thank you.
Quick housekeeping. Did you turn my mic off? Check, check. Please fill out, you'll get a speaker survey. Please make sure to fill those out. It really helps us with the content, who's up here talking, and so on. Thank you.
Are there any questions?
I was wondering do you have a target install base or market saturation threshold for this ARM processor, because I'm assuming it's the one that it's coming up, before it makes sense to release this kind of game? So meaning how many mobile devices need to have this processor for you to say, okay, we're ready? Because
Yeah, I mean, from ARM's point of view, we say that's a studio decision. Every studio is going to have a different economic model, business rules. So we would hope people take it even before it's out, like the Buzz team is doing. But we recognize, and so part of the strategic pursuit, let's say, from ARM's point of view, is to accelerate the natural adoption of technology, which usually waits for, hey, there's 10 million units out there, now we'll pick it up. We want to accelerate by lowering the cost of you making that decision, and when you make that decision, making that feel better through co-marketing, through co-publishing blogs, making sure people know about it, so giving a platform for celebrating the adoption of that technology. But I'll let Lukas speak to the specific, like how their studio makes that decision. But I think you're going to get 100 different answers to the question.
Yeah, I agree. It was in my mind. I'm developing a game for LLM inference, and so I'm thinking of releasing in about 18 months, right? And so that's why I was curious about Lukas' take.
Yeah, maybe just one other comment about how our technology proliferates. When we have a new set of technology in the architecture and a new SoC that comes out, you see those usually first come in high-end phones. The second year it hits middle, and then it sort of, the technology just proliferates down. So within 3 years, you kind of have all smartphones basically having the technology. So that's a rough math you can do. Yeah.
That's amazing presentation. Thank you. Quick question regarding your project Buzz. What's the power consumption when you have all these things on?
Well, I'm not sure I'm the right person to answer that. It's better to head back to the stage and ask, ARM people, because I'm just an artist, so I don't have, unfortunately, answer for this question. So yeah, I think there are people that know more than me. Sorry.
Okay, cool. That's fine. Another question may be out of scope. During this work, how does the AI help you? I mean, do you still need your own hands-on knowledge about all these things? Or you can ask AI for some of them, and AI can give you some answer, and you can do it?
Well, basically, like the AI in this project is used only for, giving up more performance so we can use the Unreal features. Like the game is not created by AI, it's created by people. And the AI is providing a performance budget that we can use to really just be creative, and we don't need to look that much on the performance limitations. So otherwise, all the visuals or the code is done by people, not by AI.
All right, cool. Thank you.
Okay, if that's it, so thank you very much again.
Thank you.